we're going to be continuing our lessons on functions. Yesterday, we took a look at the first standard we needed to learn in functions, understanding functions. Today, we're going to be trying to compare properties. So how can we use tables, graphs, and equations to compare functions? Well, let's go ahead and get started. If you go ahead and get yourself to the slide that says task at the top, let's go ahead and read this. So Sam wants to take his MP3 player and his video game player on a car trip. An hour before they plan to leave, he realized that he forgot to charge the batteries last night. At that point, he plugged in both devices so they can charge as long as possible before they leave. Sam knows that his MP3 player has 40% of its battery life left and that the battery charges an additional 12 percentage points every 15 minutes. His video game player is new, so Sam doesn't know how fast it is charging, but he recorded the battery charge for the first 30 minutes after he plugged it in. So part A, if Sam's family leaves as planned, what percentage of the battery will be charged for each of the two devices when they leave? In order to answer that, we need to figure out when they planned to leave. So that can be found right up here at the top. So an hour. So he has an hour. We're going to go ahead and identify some important information. So we know that Sam has an hour before that they leave, and his MP3 player has 40% battery life and charges 12 percentage points every 15 minutes. He's not quite sure about this video game player, but he did record in this table down here what happens in the first 30 minutes. So let's go ahead and figure out for the video game player what our charge will look like all the way up to an hour. So we can see that this is increasing by 10 minutes. So each one's increasing by 10 minutes. So here we would know this is 40, 50, and 60 minutes would complete our hour. It's telling me, if you look at this table, that I'm increasing by 12% each time. So if I'm increasing 12%, this would be 68%. Then I would be at 80%, and then 92%. So for the video game, we'd be at 92% charged when they leave. For the MP3 player, we can also make a table. The word problem tells us that before he started charging, he was at 40% battery life. And every 15 minutes, it's increasing by 12 percentage points. So 40 plus 12 would give me 62, and then plus 12 would give me 74, and then if I do plus 12, oops, I apologize, I wrote this down wrong. 40 plus 12 would be 52, there's my math, 52, plus 12 would be 64, plus 12 would be 76, plus 12 would be 88. So for my MP3 player, I'd be at 88%. Part B says, how much time would Sam need to charge the battery 100% on both devices? Well, let's look up at the MP3 player. If I add another 15 minutes, so I'm at 75 minutes, I would add 12 percentage points. So at 75 minutes, I'm 100% charged for the MP3 player. If I add 10 minutes down here, I would be adding another 12. So this would be 104%. Well, we know 104, something can't charge 104%. So it would take us 70 minutes. So Sam needs to be able to charge 75 minutes in order for them both to be completely charged. All right, go and take a look at the next one. Jordan and Alyssa find out they are reading the same book. Although they will be starting on different page numbers, they decided to record their progress to determine who is the faster reader. Using the results below, determine who is reading at a faster rate. Explain your reasoning. So we have Jordan and Alyssa. They're reading the same book, but they're on different page numbers. That's important. So Jordan's reading rate is the table. Alyssa's reading rate is the graph. We need to use slope. So when it's talking about determine who's reading at a faster rate, the word rate is equal to slope. And remember, slope is rise over run, or the change in y over the change in x. So when I look at Jordan's reading rate, my table, his reading time in hours is x, his page numbers in y. So let's look at this. From hour 2 to hour 3, he goes from 215 to 260. So I could subtract that. So 260 minus 215. He read, let me go ahead and calculate that, 45 pages when he went from hour 2 to hour 3. So every 1 hour, he reads 45 pages. In the graph, we can see that Alyssa started calculating at page number 40, and at hour 4, she was at 240. So we can do our rise over our run. So my rise would be 240 minus 40. So my rise is 200. And my run, I went from 0 to 4, so my run is 4. So the slope would be rise over run. So Alyssa is reading 50 pages per hour. So my answer would be Alyssa. And the last one. Frank and Francis are building houses in a computer game. Frank started with 630 bricks and is using his bricks at a rate of 15 bricks per minute. The graph shows the number of bricks that Francis has remaining as a function of time. Who will have the fewest bricks left after 20 minutes? So Frank's representation of bricks is right here. So Frank started with 630 and he's using 15 per minute. Francis is listed in the graph. So what we need to do is we need to write an equation. So for Frank, he starts at 630. That's his initial. And every minute, he's using 15 bricks. So that's his equation. So what I could do to figure out how many bricks he has left is say, well, if he started with 630 and I'm looking at 20 minutes, I can multiply 15 by 20 and I get 300. So after 20 minutes, he has 330 bricks left. To figure out how many Francis has left, I just gotta look at the table. So I'm gonna go all the way over to 20 minutes. And at 20 minutes, I'm gonna follow that up. Francis has 320 bricks left. So it says who has the fewest bricks left? That would be Francis at 320 bricks. All right, guys, if you have any questions on these, please make sure you stop by my office hours. Thank you.